The Ingenuity Mars helicopter survived a mishap during its sixth flight on NASA's Perseverance mission. For NASA, the challenge was powering an aircraft in the ultra-thin air of Mars, whose atmosphere is just 1% as dense as Earth's, making it especially difficult to generate aerodynamic lift. To compensate, engineers equipped Ingenuity with rotor blades that are larger and spin far more rapidly than would be needed on Earth. Ingenuity was commanded to climb to an altitude of 33 feet, 10 meters, before translating 492 feet, 150 meters, to the southwest at a ground speed of 9 miles per hour, 4 meters per second. At that point, it was to translate 49 feet, 15 meters, to the south while taking images toward the west, then fly another 164 feet, 50 meters, northeast and land. Telemetry from Flight 6 shows that the first 150-meter leg of the flight went off without a hitch. But toward the end of that leg, something happened. Ingenuity began adjusting its velocity and tilting back and forth in an oscillating pattern. This behavior persisted throughout the rest of the flight. Prior to landing safely, onboard sensors indicated the rotorcraft encountered roll and pitch excursions of more than 20 degrees, large control inputs, and spikes in power consumption. Except for a computer software glitch that has twice delayed Ingenuity flights, the rotorcraft operated flawlessly, meeting all technical objectives in its first 3 flights on Mars, said Mimi Ong, Ingenuity project manager at JPL. Data returned from Ingenuity showed that it covered a round-trip distance of 872 feet, 266 meters, roughly the length of 3 American football fields at a speed of almost 8 miles per hour, 3.5 meters per second. The miniature helicopter hitched a ride to Mars strapped to the belly of the NASA science rover Perseverance, a 6-wheeled astrobiology lab that landed on February 18 in a vast basin called Jezero Crater after a nearly 7-month journey through space. On its latest jaunt, Ingenuity snapped 60 black and white images and several color photos of the Martian surface while buzzing over the planet's reddish-orange landscape. The pictures will be fashioned into 3-dimensional digital elevation maps for use in selecting a suitable new takeoff and landing zone for later flights. Similar tracking operations could also be used to help mission managers conduct low-altitude science observations of sites not easily reached by a rover, and to scout for preferred rover routes to various surface destinations. Meanwhile, JPL will continue preparing Perseverance for its primary mission, a search for traces of fossilized microorganisms in Jezero Crater. Scientists expect to begin collecting Martian rock samples there in July.